Well, hey there, kiddos. We're going to finish up solving quadratic equations today, and we're going to do it with the way that's going to be everyone's favorite, because I'm going to show you how to do it by graphing, which means you get to use your calculator, and it's going to be much simpler than quadratic formula or even factoring. It's not the end-all be-all. There are some times when using your calculator is not the best because your parabola is way too big, it doesn't fit on the screen, those kinds of things, but you're still going to really like this. So remember, this was on the first page when we did this at the very beginning, but just we need to remember the roots of quadratic equations they're called our solutions. And in order to find the roots, we have to find the x-intercepts. And so this goes back to all four of those words. Roots, x-intercepts, solutions, and zeros all mean the same thing. And you're going to see questions asked that way, several ways, over and over. And so number one, give you a picture. They want the zeros of the function graph below. That just means where does it cross the x-axis? Well, it does it twice, once here and once here, and all you have to do is give me the ordered pairs for those points. This one is at negative 1, 2, 3, so it's at negative 3, 0. This one right here is right at the origin, which happens to be at 0, 0. So there are your zeros. You just pulled them off the picture. It's really easy. Number two asks you to complete a table that includes the solutions of that quadratic equation, and then they want you to graph it. And so that's what we're going to do, but we're going to use our calculator. So we're going to pull out our calculator, and the first thing we're going to do is go to y equals, and we're going to type in that equation, the x squared minus 6x. So I have x squared minus 6x. And I don't really need to look at the picture. I don't need to see what it looks like. They just want me to complete the table. So I'm going to go to second graph to look at the table for that function. And then I'm going to go back to my notes, and I'm going to fill in the table based on what that says. So we're going to fill in the values that we had on our calculator. And so at negative 1, it tells me that y equals 7. So this is 7. At 0, it's 0. At 1, it's negative 5. At 3, it's negative 9. And at 6, it's 0 again. And so now I'm going to plot these points on my graph so that I can make a parabola. So I have negative 1 and 7, 0, 0, 1 and negative 5, 3 and negative 9, and then 6 and 0. And it doesn't make a full parabola, but I can pretty much guess about what it's going to look like, so I can sketch my graph. And now I can tell my zeros, and there's two ways to find them. You can look at the picture and see where did it cross the x-axis, or you can look for where y equals 0. That's why they're called zeros. We're looking for why y equals 0, and so my two zeros are at 0, 0 the origin, and at 6, 0 is the other one. So now let's talk about how to actually use the calculator if you don't have a picture given to you already, how we're going to go about using our calculator. The steps are here, and these are the steps I'm going to follow as I go through these math problems. I'm going to follow these steps using my calculator, and so you just need to follow along with me if you have your calculator with you. So number one gives us f of x equals 5x squared plus 29x plus 20. And the very first thing it tells us to do is put that equation into y equals. So that's what we're going to do. So we're going to go back to y equals. We're going to clear out that equation, and then we're going to type that one, which is 5x squared plus 29x plus 20. Now the next step says to enter 0 under the y2, so that's what we're going to do. Now when you graph, I'm just going to tell you right now, when you graph these two equations, you probably are not going to be able to see the y2 equation. It's probably not going to show up because where y equals 0 is the x-axis. The reason why we're telling it to do that is because we're going to look for where does the parabola intersect the x-axis, and so if I put that in, it's real easy to find it. There is another way to do this, but I found that this is the easiest, so it's the one we're going to do. So we're going to graph it, and on my calculator you'll be able to see the y equals 0 because it's going to show up in red. Yours will not. It's just going to sit there for a minute, nothing's going to happen, and you're going to think it's not there. It really is. It just draws it on top of the x-axis. But I have mine, and what I'm looking for are these two intersection points. And so I'm going to have my calculator find it. So the next step, it says to do second trace. And we're going to choose option number 5, which is intersect. And now, before when we did this with straight lines, you just went enter, 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 and you were done. We can't do that now because we're going to have to tell it where to look. So we're going to hit enter and enter for the first two, but then when it says guess, we really do sort of want to tell it where to look. I'm going to take my cursor and move it over here to the intersection on the left. So I'm going to move it until that cursor is close to that 0 that's way over here. And then I'm going to hit enter because will tell my calculator, look here. So I'm going to hit enter, and so it's going to look there at that one on the left, and it tells me that that one is at -5. And so I'm going to go over here, and I'm going to write that one of my solutions is at x equals -5. Now I got to find the other solution. I'm going to repeat those steps. I'm going to go second trace, option number 5. I'm going to hit enter twice, and then I'm going to do the right arrow until I get over to that one that's on the right, so that it knows to look there. If you don't move your cursor, it's going to look in the same place it just was, and it's going to give you the same answer. You don't want that. You don't want the same answer. Okay, so it's telling me that that one is at -0.8. It's not even at a whole number, and so my other one is at x equals -0.8. Those are your two solutions to that parabola. So let's do it again. So look at number 2. It says -x squared minus 5 equals -4x. You can't do anything with it till it equals 0. So the first thing I'm going to do is make this equal 0. I'm going to add 4x to both sides. So that would make this -x squared plus 4x minus 5 equals 0. Now I'm going to go back to my calculator. I'm going to go to y equals, and I'm going to enter in that equation, which was -x squared plus 4x minus 5. And then the second one is going to stay 0, and so I'm going to graph them, see what they look like. It's important that you graph it first to make sure that your zeros show up on your screen. If they don't show up on your screen, if you can't see where it crosses the x-axis, then you're not going to be able to find them. Now, if you look at that graph that just got created, this parabola right here never, ever, ever crosses the x-axis. It goes up here and then it turns back around, but it never even touches the x-axis. What that tells me is that if I were to do the discriminant of this quadratic, I'm going to get a negative number, and the reason I'm going to get a negative number is because this never crosses the x-axis, and that means that this one has no real solutions. And so there are no answers, or no real answers that I can come up with because it never crossed the x-axis. So that's just what you say. It has no real solutions. I can tell from looking at the picture. Now this last one says to find two consecutive positive odd integers whose product is 35. Well, we got to go back to first semester when we did consecutive integer problems. First of all, it says positive and odd. The positive part we don't have to worry about till the end. The odd part's important. If you will remember, when you're doing integer problems like this, the first integer is always x. And since I'm dealing with consecutive odd numbers, the second one is x plus 2. It's telling me that the product of them is 35. That means I have to do x times x plus 2 equals 35. So I'm going to distribute. That becomes x squared plus 2x equals 35. And I need that to equal 0 so I can solve it. And so I subtract 35. So I've got x squared plus 2x minus 35 equals 0. So I'm going to go back to my calculator and I'm going to put that in. So I have y equals x squared plus 2x minus 35. And I'm going to delete all that out because I didn't clear. Let's try that again. X squared plus 2x minus 35. This is why you want to hit clear first and not just start typing over things. I don't know why it left off my plus sign. There we go. Now I'm going to graph it and look at it. So it's going to graph my parabola, and I can't see the entire thing, but I can see it crosses the x-axis once over here and then once over here. Now if I go back to my problem, my original problem said find two consecutive positive odd integers. So all I care about is the positive root, which that happens to be the one over here on the right. If I find this one, it's negative because it's left of 0. So when I do this, I only have to do one of them. So I'm going to go second trace, 5 for the intersection, hit enter twice, And you want this one over here on the right. So arrow over to the right because that's the positive one. And then hit enter. And it tells me that that is at 5. And so that tells me that one of my integers is 5. My other integer, the x plus 2 one, is going to be 7 because 5 plus 2 is 7. So my two consecutive odd integers whose product is 35 are 5 and 7. And if you do the math, 5 times 7 is 35. Yes, it works. So that is your answer. That's how you do it. Follow the steps on your paper for how to do it in your calculator. That'll make this really simple for you. I will see you tomorrow.